with the students of Gokraju Rangaraju Institute of Engineering and Technology from the Department of Civil Engineering. Myself Santosh and my major project title is 3D analysis and design of a multi-story building using StatPro. The contents for my presentation are explanation of terms in the title, phases of a project, about STAT and MS Excel, data required for the analysis of a frame, types of loads and load combinations, analysis of a beam, design of multi-story building and analysis, design of slabs, footing, staircase using Excel sheets, conclusion and references. What is a design? A design is a plan or a drawing produced to show the look and function of a building or object before it is built or made. What is structural analysis? Structural analysis is a process to analyze a structure system in order to predict the responses of real structure under the imposition of expected loading and external environment during the service life of a structure. How actually a project starts in the real world? There are the four different phases. They are planning, design analysis, construction, and maintenance. This is the flow of work. Architectural layout, then followed by structural modeling and analysis, then go with construction process. This is a working plan I have taken for my project. It is a residential G plus 4 building consisting of a double bedroom and two individual single bedrooms. This is the positioning of beams and columns. About STAD. STAD stands for Structural Analysis and Design. It is a comprehensive and integrated design and finite elements analysis tool. STAD performs the analysis and design of different types of structures. It has ability to perform more than 20 international building codes, gives fast and accurate results, reduces cost and saves labor. This is the STAD workspace. Steps to reach goal using STAD. There are the four steps to reach the goal. They are preparing the input file, analyze the input file, watch the results and verify them, send analysis results to the concrete design. About MS Excel. MS Excel is a spreadsheet tool capable of performing calculations, analyzing data, and integrating them from different programs. Worksheets perform calculations, store and organize data, present graphics and controls like a web page, and they are extremely versatile. This is a figure showing the Excel workspace. Data required for the analysis of frame. My project is type of structure is multi-story residential building. Number of stories 5, floor height 3.5 meters, M25 concrete and Fe415 steel. Specific weight of RCC is 25 kN per meter cube. Specific weight of infill is 19.2 kN per meter cube. Size of beam and columns are 380 by 450 mm. Depth of slab is 120 mm. Live load as per the codes is 2 kN per meter cube for the residential building and 1.5 kN per meter cube on the terrace. Basic wind speed and wind intensity are calculated as per IS 875 part 3. Seismic load as per IS 1893 part 1. Types of loads: dead load, live load, wind load, and seismic load. Dead load. It is defined as load due to its own weight of the structure. Live load. It is defined as load on the structure due to moving weight. Wind load. It is defined as a load on structure due to wind intensity. Seismic load. According to the acceleration response of a ground to the structure, our country is divided into four different earthquake zones. They are Zone 1, Zone 2, Zone 3, Zone 4, and Zone 5. My plan comes under the Zone 2. Load calculations. Initially, dead load calculation. It comprises of main wall load, plinth load, and slab load. Main wall load. It is calculated by multiplying the cross-sectional area of wall by unit weight of the brick. Plinth load. According to the IS code, the plinth load can be taken as half of the main wall load. Slab load. It is a combination of slab load and floor finishes. It is taken by multiplying the cross-sectional area with the unit weight of the concrete, that is 25 kN per meter cube. Live load. It is externally applied all over the superstructure. Generally, live load varies with the type of building. According to the IS codes, live load is taken as 2 kN per meter cube. Wind load calculations. Wind load can be calculated from the formula Vz is equal to Vb into K1 into K2 into K3 from the IS code 875 part 3, where Vz is the design speed of wind at a height z meters in meter per second. Vb is the basic design wind speed at 10 meter height. K1, K2, K3 can be calculated from the IS codes. Seismic load calculations. According to the IS 1893 Part 1, horizontal seismic coefficient AH can be calculated from the formula AH is equal to ZI by 2RG, where Z is the zone factor according to the structure belongs. I is the importance factor, R is the response reduction factor, and SA by G is the average response acceleration coefficient. Load combinations. For seismic analysis, the building code refers the following load combinations: 1.5 into dead load plus live load, 1.5 into dead load plus earthquake load. For wind load analysis, the building code refers the following load combinations: dead load plus 0.8 live load plus 0.8 wind load. Analysis of a beam. Now we analyze a simple beam using the STAT. It is a simply supported beam with a uniform load of 2 kN per meter cube and a concentric force of 4 kN at the midpoint. This is the 3D view of a beam. These are the analysis results of the beam. The blue line indicates the shear force diagram, green line indicates the deflection diagram, red line indicates the bending moment diagram. Steps in the design of a building. Initially, open a new project, create nodes using grid provided as per the plan, define the property of beams and columns, create the supports, give the load case details and load combinations using concrete design of IS 456, give the FC, FY and FY secondary values, give the design of beams and columns command, run the analysis for the structure. If no errors, go for a design. This is the figure showing how to create the nodes in the STAT. This is the top view design in the STAT. This is the picture of whole structure after the generation of the model using the STAT. Comprises of G plus 4 building. This is a 3D view of the structure created in the STAT. This is the assigning of dead load, where all the green color indicates the slab load and blue color indicates the wall load. Assigning of live load. This is the wind figure showing the wind load in the X direction. This is the wind load showing in the negative Z direction. This is a load in positive Z direction. This is a wind load in negative Z direction. This is the combination load case designed for the limit state design of 1.5 times of dead load plus live load. This is a deflection diagram obtained from the analysis results of the entire structure. This is the bending moment diagram. This is the shear force diagram of the whole structure. This is the results for the beam, showing the reinforcement details of each individual beam and the reinforcement details. This is the chart output for the beam, showing the sectional area, top reinforcement, bottom reinforcement, provision of spacing, shear reinforcement. Design results for the column, showing the placement of reinforcement, the breadth and width of column, showing the bar size, bar dia, number of bars required. This is the STAT output for the column. At the end of the STAT analysis, we can get the total volume of a concrete and total volume of steel used in the entire generation of the model. This is the plan showing slabs. Here we have 16 different types of slabs which are designed using the MS Excel sheets. This is the Excel sheet showing the design of slab based on the Ly by Lx value. If Ly by Lx is less than 2, we consider it as a two-way slab. Providing the values of FCK, Fy and depth of the slab, the Excel sheet performs the calculations for the reinforcement details and spacing of the reinforcement is obtained, and the checks for deflection and cracking is also done using the MS Excel sheet. This is the plan showing the footings. Here we have 25 footings, of which some are similar. The footings are designed as isolated rectangular footings. Taking the axial load coming onto the footing from the STAT, the Footings are designed for that axial load. The check for bearing pressure, check for punching failure, check for one-way shear, and check for bearing are done using the MS Excel sheets. This is a plan showing the location of staircase, which is 3.24 meters by 2.1 meters. The staircase is designed using the MS Excel sheet, providing the length and width of the staircase, providing the FCK and FI values, riser and tread of the staircase. The staircase is designed for the limit state design, and the reinforcement details are specified, and center to center distance of the reinforcement is obtained. Conclusion: the design of slab, beam, column, rectangular footing and staircase are done in limit state method, which is safe at control of deflections in all aspects. Using StatPro, the design consideration has been taken as IS codes. The design is safe in all conditions. The percentage of variation in area of steel for the beam, column, footing and slabs are less than 20% of the required steel. The references for my project are IS 456-2000 Indian codes, IS 875 1987 Part 1 for the dead loads, IS 875 1987 Part 2 for the live loads and wind loads, SP 16 design aids for the reinforced concrete, SP 34 handbook for the reinforcement detailing, IS 1893 1984 for the earthquake resistant design of structures, illustrated design of reinforced concrete design by VL Shah and late Dr. S.R. Coway, design of reinforced concrete structures by Mr. Dhirendra Babu, theory of structures by Ramamtram. This is the end of my project. Thank you.